Good morning, everyone, and welcome to the Tejano Virtual Events Happy Math Hour. This session is on standard form of quadratic equations and graphing for the Math 1314. If you are going to Math 1324, there will be an exam for review. So please, at this time, mute your mics so you can enjoy the experience and you will not be a distraction. If you want to come back to this presentation at a later time, this presentation will be recorded and available on our YouTube channel. Okay, so thank you. So now at this time, please welcome Mr. Ruben Carrizales and Ms. Yvette Chuca.
Hello, everyone. Welcome to Friday Happy Math Hour. If you are here for 1324, they just posted the link. You can click on that and it'll take you to the 1324 session. If not, we're going to get started with the 1314 section. At any time, if you have any questions, feel free to put them in the chat or ask them. All right, so let's get started. So now we are going to be looking at chapter 2. And so for chapter 2, we're going to be focusing, the first section is going to be focused on quadratic functions. And then the rest of the sections are going to be focused on basically equations that have a degree higher than 2. And so for the quadratic equations, we know that it's quadratic if the highest power of x is a 2. Okay, so if you notice here, we have ax squared plus bx plus c. The highest exponent is a 2. So automatically, that's going to tell us that the graph is quadratic. And more importantly, if you were to graph it, the shape of the graph is a parabola. So it looks like a U shape. Now the parabola can either open up or it could open down. Okay, so we also say that the parent function for the quadratic family is f of x equals x squared. So as I mentioned earlier, the parabola is either going to open up or it's going to open down. And so if it's going to open up, it's going to have a positive coefficient in front of the x squared. So in this situation, in front of x squared, we see a positive a. That's why the graph is going to open up. And then Mr. Lopez, go ahead and ask your question. Mr. Lopez, we can hear you if you're trying to speak. Okay. All right. So if you look at the second one on the right side, we have a negative x squared. And so for negative x squared, we have a coefficient in front of the x squared, which is negative. So that's going to cause the graph to open downward. Okay. So from now on, if you see a negative in front of the x squared, it's going to go ahead and open downward. And then some other things to keep in mind. Again, if it's positive in front of the x squared, it opens up. If it's negative, it's going to open down. And the bottom part of this parabola here, we call it the vertex. And one way to find the vertex is to use this formula here, where your x coordinate is negative b divided by 2a, and your y coordinate is f of negative b over 2a. And then for the other side, the parabola didn't come up, but the parabola here is opening downward. So let me just draw it really quick. So your parabola is going to open downward. And these green lines that we see here, these green lines are called the axis of symmetry. And the axis of symmetry is always going to pass through the x coordinate of your vertex. So whatever this point is here, that's going to be your axis of symmetry. So we're going to break it down in detail in a second. So the general form of this quadratic formula is going to look like this: f of x equals ax squared plus bx plus c. However, we can write it differently as a standard form, and the standard form looks like f of x equals a parentheses x minus h squared plus k. Now the standard form is convenient to help us sketch a parabola, because we know that if we have a minus h in here, we know that the graph shifted to the right that many units. And if we have a plus k, we know that the graph shifted upward so many units. So it makes it a little bit easier to sketch the parabola. It also tells us what the vertex is going to be. So the vertex is going to be a positive h, so the opposite of what you see in here, positive h, and then we keep the k, and that's going to be your vertex. And again, we're going to see examples here in a little bit. So one of the things that you're asked to do in section 2.1 is to take this general form of the quadratic equation and write it in standard form. In order to do that, we use something called completing the square. So I'm going to break this up into different steps. So the first thing you want to do to rewrite this in standard form is we want to make sure that the number in front of x squared is a 1. So in this example, we don't have a 1, we have a 4. So we're going to have to rewrite it so that we can factor out the 4. And so to do that, notice that I'm going to group my two terms that have x's in them. I'm going to group them together with parentheses. And now we have 4x squared plus 8x. So 4 and 8, we can factor out of 4 of each of those. If I take out a 4 from the x squared, then I'm left with x squared. And if I factor out a 4 from the 8, it's the same as saying 8 divided by 4. And so that becomes 2. So basically, what you end up with here is 4 times x squared, which is 4x squared, and 4 times 2, which is 8x. Okay, so now that we have a 1 in front of the x squared, then we're going to be able to proceed. So the next step is to take half of b. B is always going to be the number that's in front of the x. So in this case, the number in front of x is 2. So we're going to take half of it. So to take half, we divide by 2, and we get a 1. Now what we end up with here, we're going to square that number. So 1 squared, so that would be your next step here. So we're going to take the 1, we're going to square it, and we get a 1. Now this result, we're going to put it back into the parentheses. But what we want to do is we're basically wanting to add a 0. So what we're going to do to make that happen is we're going to add a positive 1 and a minus 1. Why do we want to do this? Because we don't want to change the problem. And adding 0 does not change the problem. So positive 1 minus 1 is just 0. So it's not going to change the problem. It makes it look different, but it's still the same equation. Okay. So now what we have here is our polynomial. And so what we want to do next is and it sounds silly, but what we want to do next is we want to remove this negative 1. So you might be saying, well, didn't we just put it in the parentheses and now you want to take it out? Yes. Okay, and you're going to see why here in a second. Now to remove it away from the parentheses, we have to consider that there's a 4 in front. So if I remove this negative 1, whatever is in front, I'm going to have to multiply that negative 1 by that number. So here I'm going to have 4 times negative 1 is negative 4. So this negative 4, we're going to just go ahead and write it on the outside of the parentheses. And so now we still have the 4, but in the parentheses, we're left with x squared plus 2x plus 1. And that's where the magic is going to happen for us in a little bit. Okay, so 16 minus 4 is 12. So now we can look at this parentheses. So this process, what it does for us is that it makes this inside a perfect square. And so x squared plus 2x plus 1, we can write it, we can factor it out, and we're going to have x plus 1 times x plus 1. So if you multiply x times x, you get x squared. X times 1 is 1x, 1 times x is 1x, so that gives us a 2x. And then 1 times 1 will give us that positive 1. Now there is a shortcut to figure out what number goes here in this 1. And that shortcut is the number you get from taking half of the letter B, which I'll restate here in the next example. But now that we have two identical factors, we can rewrite them as x plus 1 squared. And so now we've taken the general form, we wrote it as a standard form. So having it in standard form, we can get the vertex. So your vertex is going to be the opposite of what we have in the parentheses. So instead of +1, it's going to be a -1. And so let me go ahead and put it here. So we're going to have a -1, and then we keep the number outside, which would be 12. And so that's going to be your vertex. Once you have your vertex, then you'll be able to graph the equation a little bit quicker. Okay, so I do have about 2 or 3 examples on doing this so that we can see the different situations. So let me start with the next one. So here, what is your first step? To make sure that the number in front of x squared is a 1. And if you notice here, it's already a 1. So that's good for us. Okay. Since it's a 1, we don't have to do anything. But I'm still going to group my two terms that have variables in it. So x squared plus 2x. And then I'm going to leave a gap here because remember, we're going to insert something in there. And then I have my +1. So your next step is to take half of 2. So that's going to be take half of 2. So 2 divided by 2 is 1. And then we're going to square it. So 1 squared is going to be 1. Once you get the number that you squared, then we're going to add it back into the parentheses, and we're going to subtract it. Okay, so now we want to remove this -1. If I remove it, you always want to make sure, is there anything in the front of the parentheses that I have to multiply? So here we don't have anything. Well, we have a +1, but 1 times this -1 is just -1. So we're going to have our -1 here, and then we have our existing +1 that was already there. So if we simplify, 1 plus -1 is 0. If we factor the parentheses, we get x plus 1 times x plus 1, which is going to be x plus 1 squared. So to find the vertex, we take the number in the parentheses, the opposite number, so -1. And then there's no k, right? The k is 0. So that's going to be our vertex. Now the axis of symmetry, remember, is the x coordinate of your vertex. So our axis of symmetry will be x equals -1. Okay, so this one has a number in front, so that's good. And it looks a little bit different than the previous one, so that's always good as well. So we'll be able to see a little different situation, right? So again, your first step is ask yourself, do I have a number 1 in front of the x squared? The answer is no. So we need to factor out that 2. So I'm going to rewrite it, separating my two terms with the x's in them. And now I'm going to factor a 2 out of here. So when we say factor out, basically you're dividing 2 divided by 2 and 8 divided by 2. And so if we do that, 2 divided by 2 is 1. So I factored out my 2. And then 8 divided by 2 is 4. So to double check your work, if you multiply the 2 in here, you should end up with the same thing up here. So 2 times x squared is 2x squared. 2 times 4x is 8x. Now that we have a 1 in front of our x squared, we're going to take half of b. So my b is 4. I'm going to take half of it. 4 divided by 2 is 2. And then your third step now is to square your result. So if we have 2 and we square, then we end up with 4. Okay. So 4 is the number that we want to add and subtract into the parentheses. And now our next step is to get rid of this -4. So this, let me get my pen out. So we're going to take this number and we want to remove it from the parentheses. But in order for me to remove it, I'm going to have to multiply it by whatever is out here, which is a 2. So 2 times -4 is -8. And so -8, we're going to go ahead and add it to the +7. And I should have this on the next slide, but I just wanted to draw it so that you can see it there. So let's go ahead and do that. So -4 times 2 is -8. So -4 times 2, -8. Simplify. So we get -8 plus 7 is -1. If we factor the parentheses, we get x plus 2 times x plus 2. Remember I said there was a shortcut. After you took half of 4, we got a 2. And so that's the number that you use here. So 2 and 2. So now x plus 2 is going to be x plus 2 squared. And so now we have it in standard form. So my vertex is the opposite of what I have in here. So instead of plus 2, it's negative 2. And then I keep my k as negative 1. The axis of symmetry is your x coordinate, which would be negative 2. Okay, so right now we're looking for the vertex, and then we're going to start finding the zeros so that we can be able to graph the entire parabola. Let's try one more that is not using even numbers, so maybe we'll end up with fractions, maybe. So if we go through the steps, we want to get rid of that 5. So first, I'm going to write my terms together in parentheses. I'm going to take out a 5 by factoring it out. Basically, 5 divided by 5 is 1, so that's how we get the 1 here. 15 divided by 5 is 3, so that's how we get the 3. Again, double check your work. 5 times x squared is 5x squared. 5 times 3 is 15x. Our next step is take half of 3, so we're going to have 3 divided by 2, so that's a half, and then square it. So I'm taking half, 3 divided by 2, and then I'm going to square it. So I get 9/4. Okay. So what do we want to add is 9/4 minus 9/4. And then we continue. So now we want to get rid of this negative 9/4. So we're going to bring it out, but we have to multiply it times 5. Okay, so here we're going to get, and I do the work on this side. So we're taking negative 9/4 times the 5. So we end up with negative 45 divided by 4. So that's how I get this negative 45 divided by 4. And this minus 5 is just the same that we have before. Okay, let's simplify further. So first, let's look at the factoring this. So if you try to factor x squared plus 3x plus 9/4, that could seem difficult, right? But if you keep in mind that shortcut I told you earlier, we know we're going to have two parentheses. We know I'm going to have x and x. What is that missing number here? It's always going to be your half. So if you had 3, you took half of 3 is 3 divided by 2. That's what we're going to use here. And if you double check, 3 times 3 is 9. 2 times 2 is 4. Okay, so that takes care of the factoring here. Now over here, in order for me to add negative 5 and negative 45/4, I need to have a common denominator. So that common denominator is 4. So the 5 can be written as 5/1. And if I multiply by 4 in the denominator and 4 in the numerator, then 5 times 4 is 20. And then we end up with 4. So negative 20 minus 45, simplify here, and we get negative 65 divided by 4. So my vertex would be negative 3/2 and negative 65/4. Okay, so the next question is write the standard form of the quadratic function whose graph is the parabola shown. So notice here you have a parabola. Always look for keywords. Your keyword here is write the standard form. So what you want to do is, what is the standard form? So I'm going to write it as f of x equals ax minus h squared plus k. That's your standard form. I know that the vertex, if given the standard form, is hk. And then you're going to need one additional point. So these are the things that we need. And so let's see if we have that information. So the vertex is negative 1 and 1. At least one other point. You want to pick a point on the graph that you know for sure. So in this case, I can pick 0, 0. And then we're going to plug in the information. So here we're going to have f of x. So f of x is going to be your y coordinate, so 0. Then we have a. X is going to be 0. And then we have minus h. Well, h is negative 1 from the vertex. And then k is negative 1. Okay. So what we're doing is really solving for a. So we're going to simplify here. 0 minus -1 is +1. If we square it, we get a 1. And so we end up with a1 minus 1. So we're going to add 1 on both sides, divide by 1, so we get a is equal to 1. So we can write our equation. I already know that a is 1. And then I have x minus h is -1, and then k is -1. So negative negative is positive, and so this would be our equation. Let's try another one. Here the difference is they don't give me the graph, but they give me the information. So they give me the vertex and a point. So again, we write the standard form. Your f of x is your y and your point. So we're going to replace f of x with 3. Then we have a, x is 0, okay, minus -3 squared, and then k is -15. So if we simplify, negative negative is +3. If we square it, we get a 9. I'm going to go ahead and add 15 on both sides. So 15 plus 3 is 18. Divide by 9. So 18 divided by 9 is 2. So now we know that a is 2. So I can replace it in here. X minus h is -3. And then we have our k. So our equation is going to be 2 times x plus 3 squared minus 15. Okay, so now to find the x-intercepts, remember that the x-intercepts occur when y is equal to 0. And we have different names for them. We have x-intercepts, zeros, roots, solutions. So if you hear any of these 4 names, they're talking about those points that cross the x-axis. So how do we find those points? There's different ways to find the points. You can use the square root property. You can use factoring. You can use quadratic formula. But some of these forms don't always work. Okay, so the first 2 don't always work. Quadratic formula always works. And then sometimes a parabola or a quadratic equation might not even have x-intercepts. Okay, so we'll just briefly go through some of these. The square root property. You can use the square root property if you only have an x squared term. If you also have an x term, then you cannot use the square root property. So we have the first step is let the y equal 0. So f of x is 0. And then we're going to solve for x. So we're going to add 4. So we get 4 equals x squared. Take the square root on both sides. So x is equal to plus or minus 2. And so what that means is if you were to graph this, let me just draw it really quick. If you were to graph it, then you're going to have a point at 2 and one at -2. And your parabola is going to cross through there. Okay. So let's look at the next one. So it says solve. If you see the word solve, they're looking for the x-intercept. So we let y equal 0. In order to use the square root property, we're going to add 27 on both sides. So we get 27 equals 3x minus 4. Before you can take the square root, whatever's being squared has to be by itself. So we're going to take the 3. We're going to remove it. So we have 27 divided by 3 is 9. The term that is being squared is by itself, so we can take the square root. And then we get that x minus 4 is equal to the square root of 9, which is plus or minus 3. Add 4 on both sides. So one answer is x equals 4 plus 3 is 7. The other answer is x equals 4 minus 3, which is equal to 1. Now for factoring, f of x is equal to x squared minus x minus 6. Again, factoring, in my opinion, is great because it's a little bit quicker. But the problem with factoring is that it doesn't work for everything. So what I tell my students is give yourself a minute. If you can't factor it, move on to a different method. In our YouTube channel for the Happy Math Hour, you can go through the spring semester videos and you should be able to find a factoring video. So it's a video that just goes over all the factoring. on how to factor. So the first step is let y equal 0. So then from here, we're going to have two parentheses. So x squared is x times x. And then we have a minus 6. So if this sign is negative, that means that one of these would be negative, one would be positive. If it's a positive, that means that the signs have to be the same. So now from here, factors to give you 6. So what two numbers can you multiply to give you a 6? But if you add or subtract, would give you a 1. Okay, so in this example, we have x minus 3 times x plus 2. You can ignore this equals 0 since it's already on this side. Once you have two factors, then we can set each factor equal to 0. So we get x equals 3 and x equals negative 2. And then the last one is the quadratic formula. So the quadratic formula works for everything. It's x equals negative b plus or minus b squared minus 4ac divided by 2a. And remember, a is going to be the coefficient in front of x squared. In this case, it's 1. B is the number in front of x. In this case, is negative 2. And c is the constant, which is negative 8. So we plug in all these numbers. So we have negative b, which is negative 2, plus or minus b, which is negative 2 squared, minus 4 times a times c divided by 2 times a. Simplify. So negative negative is positive. Negative 2 squared is 4. Negative times 4 times 1 times negative 8, positive 32. 4 plus 32 is 36. The square root of 36 is 6. And so here we have some possible answers, right? So 2 divided by 2 is 1, and 6 divided by 2 is 3. So my two answers would be x equals 1 plus 3, which is 4, and x equals 1 minus 3, which is negative 2. So my two zeros are x-intercepts, solutions. Roots are x equals 4, x equals negative 2. Okay, so now we're going to go into a little bit of 2.2. So what is a polynomial? A polynomial is a function that if you graph it is continuous. In other words, you can draw it without lifting your pencil. So this is an example of a continuous graph. It's not going to be a polynomial if you have to lift your pencil up. So this is not an example of a polynomial. Polynomials also have smooth, rounded turns. So like this example is smooth and rounded. If you have a sharp turn, then it's not a polynomial. In these polynomials, we want to identify how do these graphs behave at the end of the to the right and to the left. So I have four functions that we should be familiar with. We have the parent function x squared, and we know that the graph is a parabola that looks like this. If we have a negative, then we know that it's going to open downward. And then for x cubed, this is a cubic parent function. It's going to behave in this form here. And if we have a negative, then it's going to reflect and it's going to have this form. The reason I put these four functions is because number one, to remember the end behavior or the leading coefficient test, if you look at your book, they'll give you a lot of like the definitions. It's a lot of reading, right? But if you remember these four functions, you'll always know what the leading coefficient and how the behavior of these polynomials will work. In order to determine the behavior, there's two things that you have to look at. One is you have to determine if the power is even, like we have here with the 2, or if it's odd. Okay. The second thing you have to look at is if the leading coefficient is positive or if it's negative. So from now on, if your leading coefficient is positive with an even degree, the behavior is always going to look like this one. In other words, if we look at the graph to the left, it's rising, it's going up. If we look on the right, it's also going up. If the degree is even with a negative coefficient, then notice that to the left, the graph is falling. So we say it falls to the left. And then to the right, it's also falling. But if the degree is odd with a positive leading coefficient, then we say that to the right, it's rising to the right, and then it's falling to the left. And then for this one, if it's negative with an odd coefficient, negative leading coefficient with an odd degree, then we say that it rises to the left and falls to the right. Okay, so in here, this is what I just wrote or what I just said, right? So degree is even, positive coefficient, it rises right, rises left. If it's even coefficient, even degree, negative coefficient, it falls right, falls left. And then for the next two, same idea. Okay, so this is gonna tell us the behavior is of any function. So for example, I have four graphs here, and we want to know what happens on the left side and right side of each of these graphs. So first, you need to know what the degree is. The degree is going to be the biggest or the highest exponent that you see. So here I have an 8, I have a 2, a 5, and a 1. So the degree of this polynomial is 8. Okay. So now you want to ask yourself, is 8 even or odd? So it's even. Okay. So now you want to look at its coefficient. It's 3, it's positive. So now the behavior, you have four choices, right? 1, 2, 3, 4. So it's even. So now it's between this graph and this graph, but it's positive. So now that tells me that I'm going to use that first graph. Okay, so the behavior, so where it's going to look like this one. So we would just write that the graph rises to the left and rises to the right. Okay, so let's look at the second one. The degree is, I have a 3 here and a 2. So my degree is going to be the highest one, which is 3. So now that means that I'm looking at this graph over here to the right, or this one over here. Now the leading coefficient is negative. So that means that we're going to be using this last one to determine the behavior. So our answer for this is going to be the graph will rise left and fall right. So it's rising left, falling right. So now let's look at this letter C. So we have x to the 6 plus 3x to the 5th minus 4x to the 8th plus 8. So in your mind really quick, ask yourself, what is the degree? Is it going to be 6, 5, 8? Okay. And so hopefully you're saying that it's 8. And so now you look at the coefficient, which is negative 4. So the behavior is going to be like this second one. So we'll say that the graph will fall right and will fall left. Okay. Now the last one, we have negative 2x cubed plus 9x squared plus 8. So I have a 3 and a 2. So I'm going to have an odd degree. And in front of x, do I have a 1 or do I have a negative 2? If it's like this, we need to make sure that we distribute that negative 2. So making this a negative 2x cubed. And so my behavior is going to be like this last one here. So we say that the graph rises to the left and falls to the right. Okay, so that is your end behavior. Why is the end behavior important? Well, because what we're leading to, which you'll see next week, is how do we take all this information that we're just seeing and how do we come up with a graph? Okay, so in order to graph something, we're going to have to know what is the end behavior. And then the other thing you have to know is if we look at these three graphs, notice that at my zeros, these are all my zeros here, right, where the graph crosses the x-axis. Some of these zeros, the graph goes right through them, but in some places, the graph touches and then it turns, okay? So like here, it touches and then it turns, but in this one, it just goes right through it. The same with this one, it goes through it, and then here it touches and turns, and then it goes through it. So what causes the graph to do that? What causes it to touch and turn or cross, okay? And so the to determine if it crosses or touches, we do look at the zeros. So in this first example, we have that the zeros are x equals 2, x equals -1, and x equals 4. In this second one, we have x equals -2, x equals 2, and x equals -2. So if we were in class right now, I would ask, what is the difference between these zeros and what's happening with them if you compare to this one over here. So one thing to look at is that in this second graph, we have x equals -2 and x equals -2. It's repeated. You have two of them, okay? So if a zero is repeated an even number of times, then the graph is going to touch and then it's going to turn. If it only appears an odd number of times, so like x equals 2 only appears one time, x equals -1 appears one time, x equals 4 appears one time, that means that the graph is just going to cross through it like it does here. Now, if you look at this third one, at x equals 0, we have 2x equals 0. So we have 1, 2. So x equals 0 appears twice. And by appearing, the word you're going to see on your homeworks is they might ask you, what is the multiplicity of x equals 0? So what they're asking you is, how many times does x equals 0 occur? Well, the multiplicity is 2 because it appears twice, okay? So since it appears an even number of times, then the graph is going to touch and then it's going to turn. For x equals 2 and x equals -2, the multiplicity is 1 because they appear only one time. And so that's going to cross through that graph. Okay, so basically everything I just said is what is on this slide. So again, we use the word multiplicity to determine how many times the zero has occurred. And then it tells us if it's an even multiplicity, then it's going to touch and turn. If it's an odd multiplicity, it's going to cross. The reason I have these parent functions here is because they can also help you remember. So like here you have, if you find the zeros, we would set 0 equals 2x squared. If we solve for x, we get x equals 0 and x equals 0. So it appears twice. So it's going to touch and turn. For x cubed, we have x cubed is x times x times x, which means that we have 0 equals x, 0 equals x, 0 equals x. So x equals 0 appears 3 times. That's why it touches. That's why it goes right through it. So here it looks like it touches and then it just stays there, but it's really going right through that x equals 0 point. Now that we have talked about that, let's do an example. So it says find all the zeros and determine the multiplicity. So find all the real zeros means to find the x-intercepts, which means first we have to let f of x equals 0. So we're going to put f of x equals 0. Then you want to ask yourself, this is quadratic, so I can either factor or use a quadratic formula. Again, I always like to try to factor first. So in this example, it does factor. Once I have my factors, I can set each factor equal to 0. So I get x equals 1 and x equals 1. So these are my zeros. And what do we notice about the 0? They're the same. Okay. So the multiplicity at x equals 1 for this 0 is 2 because it appeared twice. Okay. So the 0 at x equals 1 occurs twice, which is this one and this one. It's even, therefore the graph will touch and turn. And if I graph it, it touches at x equals 1 and then it turns. Okay. Let's try a different one. So now this has degree of 4. So we need to find the zeros. So again, to find the zeros, we let f of x equal to 0. Notice that they all have at least a t in common. So I can factor out a t squared from each of these terms. So I get t squared times t squared is t to the 4th. If I take out a t squared from here, I'm left with the t. And if I take t squared out of here, I'm left with -30. So if you multiply this times the parentheses, you should end up with the same thing. Now, whatever's left in the parentheses, I can try to factor. It does factor as t minus 6 times t plus 5. And then now I have three factors, so I can set each factor equal to 0. So 0 equals t squared, 0 equals t minus 6, and 0 equals t plus 5. I'm going to go ahead and solve for t. So if I take the square root here, I get t equals 0, t equals 6, and t equals negative 5. So this 0 at t equals 0 occurs twice. But you might be asking yourself, why I only see it once? 0 equals t. So one of the mistakes I see people make is that they go ahead and use the square root property here and they get t equals 0. But in reality, if you have 0 is equal to t squared, then we can write this as 0 equals t times t. And if we separate it, now we have 0 is equal to t and 0 is equal to t. So you're actually getting two zeros. Or you can think of it when you take the square root here, you get a plus or minus, right? So you get a plus 0, which is 0, or you get a minus 0, which is also 0. So your t equals 0 appears twice. Therefore, the multiplicity for 0 is going to be 2. So at this point, it's going to touch and turn. At t equals 6, it's odd because it only appears one time. And then at t equals negative 5, it appears one time. So that has multiplicity of 1. So the graph is going to cross. And I think I graphed it for us so we can see it. So at t equals 0, it touches and turns. At t equals 6, it crosses. And at t equals negative 5, it's going to cross as well. Okay. So now we get to try it out, right? So it says sketch the graph of g of x equals x cubed minus 3x squared. First thing you want to do is identify the end behavior. Second thing is find the zeros. Third thing, find the y-intercept and then plot additional points. So let's look at the end behavior first. The degree is 3. The leading coefficient is positive. So the graph is going to rise to the right and fall to the left. Find the zeros. We let y equals 0. I have an x squared and an x cubed, so I could factor out an x squared. And so if I solve for x, I get x equals 0 and x equals 3. So x equals 3 appears one time, so the graph is going to cross at that point. And at x squared equals 0, that 2 tells you that the x appears, that this 0 is going to appear twice. So we have x equals 0 and x equals 0. So that's even. It's going to touch and turn. The y-intercept is whenever x is 0. So if I substitute 0 for my x's, I get 0. So my y-intercept is 0, 0. And so to graph everything, we'll put it together. So first, go ahead and plot the x-intercepts, which is at 0, 0 and 3, 0. Then plot the y-intercept, which happens to be the same one here. Now we're going to apply the end behavior and the multiplicity to these 2 points here. So the end behavior says that the graph will rise to the left. No, it's going to rise to the right. So I'm just going to draw a little thing going up, right? Because it's rising to the right. And I know that at x equals 3, the graph is going to cross. So I kind of made a cross here. And then to the left, it's going to fall. And at x equals 0, it's supposed to touch. So I'm just going to leave it like this. Now the last step is to plot extra points. So you want to plot extra points where they might be needed, like between the zeros. If I plot a point on this side, well then my answer is going to be over here somewhere because the graph is going down. If I plot it here, it's going to be up here somewhere. But I don't really know what's going on between the two zeros. So this would be a good place to pick points. So let's plot some extra points. So I'm going to use 1 and 2. So if I plug in 1, I get 1 squared. That should be a cube. So 1 cubed minus 3 times 1 squared, that's going to give us a negative 2. And if I plug in a 2, 2 cubed minus 3 times 2 squared is going to give us a negative 4. And if you wanted to, you could also do 2.5. So now that we did that, here is my 1. It gives me negative 2. My 2 gives me a negative 4. And then I did 2.5. So that tells me it goes back up. So now I can just sketch the graph. Okay. And so this is the graph using the decimals. So it looks like it, right? So when you're doing these, usually on WebAssign, it gives you multiple choice. So I do encourage you to draw it on paper first and then see which graph is going to match it better. Okay. So that was 2.2. For 2.3, let me go ahead and just go to skip that. So one of the questions in 2.3 is to use long division. And so in order to do long division, you have to make sure that your polynomial is in descending order of powers. So we write it as 20x cubed minus 35x squared plus 23x minus 6. And then this also has to be in descending order. So 4x minus 3. So what you want to do is you want to rewrite it as to look in this format. If you're missing something like, let's say you don't have an x squared, then you still want to include a placeholder. So I would write 0x squared. Okay, so what you want to do next is you want to take this first number and divide it by this first number in the divisor here. And so I'm going to do it on the side. So 20x cubed divided by 4x is going to be 5x squared. So that's what's going to be up here. Why? Because 5x squared times 4x is going to give you that 20x cubed. And so if we multiply out, then we get 5x squared times 4x is 20x cubed. 5x squared times 3, or negative 3, is negative 15x squared. Now, if we were dividing any number, for example, the next step is to subtract, right? So if you had, for example, let's say 4 and 4 and 20, something like that, then I could say this is 5. 5 times 4 is 20. And then we subtract. And then we get 3. And then we bring down the next number. So same idea here. This is why I put the negative out here, because I'm subtracting. But we're subtracting the entire thing. So that's why I have parentheses. So when we do that, then we're changing the signs for each of those terms. Okay, so I'm going to have, if I distribute this negative in here, then I end up with negative 20x cubed. And negative negative is positive 15x squared. So 20x cubed minus 20x cubed is 0. Negative 35x squared plus 15x squared is going to be negative 20x squared. Bring down the next term, 23x. And now we repeat the same process. So 4x, so negative 20x squared divided by 4x, that's going to give us 5x. So negative 5x times 4x is negative 20x squared. Negative 5x times negative 3 is positive 15x, but I always have this negative, right? Because we're subtracting. So negative negative will make it positive, and positive will make it negative. And so let's go over here. So positive and negative. So this will cancel, and then 23x minus 15x is going to be 8x, bring down the 6. And then we start the process over, right? So 8x divided by 4x is 2. So 2 times 4x is positive 8x. And then 2 times negative 3 is negative 6. But we're changing the signs, and we end up with 0. Okay. So now some of these names are important here. The last number here, we get the remainder. That's called the remainder. The thing you're dividing by is your divisor. The end side is your dividend, and your answer is the quotient. So your answer, we write it as our quotient, 5x squared minus 5x plus 2, plus the remainder of 0 divided by the divisor. Now, long division is one way to do this, but there is a different way which is a little bit faster and quicker, I think. And so that's the synthetic division. And in order to use synthetic division, your divisor, the thing you're dividing by, has to be in this format, x minus c. So if we had this problem, well, let me just explain this part. So the way it works is you write down the coefficients. So everything that is a coefficient. And then your c is going to be your k here. We're going to drop down the first ones, and then we're going to multiply k times a, and we write it in here. Then we're going to add it to the b, and then we're going to continue the same process. Okay. But with numbers, it'll be easier to see. So let me just go ahead and do an example. So it says use synthetic division to divide. You still have to have these in order, in descending order. And so here it says, what is our k? So our k is going to be 1. So I'm going to write the 1 out here. Next, we're going to list the coefficients. The number in front of x squared is 1. The number in front of x is 5. And the number in front of 6, or the constant, is 6. So first step, bring down the 1. Second step, 1 times 1 is 1. So we're going to add, go ahead and put it up here. And then 5 plus 1 is 6. So we're adding. And then we start again. So 1 times 6 is 6. So we write it up there. And then we're going to add 6 plus 6 is 12. Okay. So now the way we're going to get our answer out is that last number. That's your remainder. Okay. So that's your remainder. And then the dividend, this is just what was inside, right? But these two numbers before the remainder is what's going to make up your quotient. So to write your quotient, we're going to take 1 degree less. So if your original problem was x squared, when you write your quotient, you're going to go 1 power less. So instead of x squared, you're going to go with x. So this 1 will start with x. So that's going to be x plus 6. So that's going to be your quotient, x plus 6. Then your remainder is 12 divided by your divisor, which is x minus 1. Okay. So let's try another one just so we can make sure. So here I have x cubed, x squared, x, and then 32. So just making sure I have everything. So my k is going to be 8. I'm going to write my coefficients. I'm going to bring down the 4. I'm going to multiply 8 times 4 is 32. Add it to the 36. We get 68. 68 times 8 is 544 plus 36. 580 times 8, 4,640. Subtract the 32, and we get 4608. Okay, your remainder is 4608. So that means that the 3 numbers before it is going to make up your quotient. Since you had an x cubed, you're going to start with x squared. So for 4, we're going to say 4x squared, and then that would be plus 68x plus 580 plus your remainder divided by your divisor. Okay, let's try another one. So here my c. So here my c is not, my k is not going to be 7. I have to rewrite it first so that it looks like this. So x plus 7 I can write as x minus negative 7. So my k is going to be negative 7. Okay. So it's always the opposite of what you see in here. You see positive 7, you use negative 7. Now the coefficients, we have 3, 2, 1, and then 42. Notice up here, they were not in order. So first I went ahead and put them in order. So 3, 21, negative 6, and negative 42. Bring down the 3. 3 times negative 7, negative 21, plus 21 is 0. 0 times negative 7 is 0. Plus negative 6 is negative 6. Times negative 7 is positive 42. And then we end up with a 0. So whenever you get a remainder of 0, that's always going to be a good thing in the next section, which we'll see next week. But the coefficient or the quotient, we had an x cubed, so we're going to start with x squared. So we're going to have 3x squared. Okay, there's no x, so I leave it as 0x, and then you have your minus 6. So my quotient is 3x squared minus 6. Okay, I think we have space for one more, so we'll go ahead and do that. So here, notice that there's no x, so I'm going to use a placeholder of 0x. And so my k is going to be 5. And then my coefficients are going to be 1, -3. I don't have an x, so it's going to be 0. And then our 6. Bring down the 1. 1 times 5 is 5. Plus -3 is 2. Times 5 is 10. Plus 0 is 0. And then we get 50 and 56. Your degree was 3, so when you write your quotient, it's 1 degree less. So this one would be x squared plus 2x plus 10 plus your remainder divided by your divisor. Okay, so um, I guess I have 4 minutes, so I can use them. So find this, how can we use synthetic division? How does that even help us? Well, if they tell you to find all the zeros and you have x is equal to -2 as a zero, if you know at least one zero here, then we can use synthetic division. So notice that this is cubic. And so if we write the coefficients, we have 2, x squared is 0, -7, and then 2. So they tell me that -2 is 0. So if I bring down the 2, I get -4 plus 0 is -4 times -2 is 8 plus -7 is 1, then -2. And notice I get a remainder of 0. And that should happen because they told me that -2 was 0. But the important thing now is that if you get the quotient, since we had an x cubed, you're going to start with an x squared. So 2x squared. And let me go ahead and write the quotient. So 2x squared minus 4x plus 1. Why is that important? Well, because now what's left is quadratic. So since it's quadratic, you can either try to factor, use the square root property, or the quadratic formula. And so this problem doesn't factor, so I would use the quadratic formula, right? That's a quadratic formula here. And so if I plug in our numbers and simplify, and so here I'm just simplifying, then we get that x is equal to 1 plus I have square root of 2, or you can write it as square root of 2 over 2. But now that our goal was to find the zeros, then you can have 1 0 is x equals -2 because they told me that was a 0. But my other two zeros came from solving using the quadratic formula for this. Okay, so I'm out of time, but on next week, we'll just continue with this PowerPoint. If you want to download it, which I encourage you to do so, where my mouse is right now, there's a box with an arrow pointing down. You can click on that and it'll give you the whole PowerPoint. As you notice, this has 390 slides. So depending on time and everything next week, we might not get through the whole thing. But at least you'll have the slides with you. So I'm going to go ahead and pass it over, and thank you for coming out today.
Thank you, Ms. Chuka, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TV sessions. Please take the time to fill out the survey. Before you leave, I want to share the TV sessions that we will have next week. Like Ms. Chuka said, on July 5th, Math 13 14 will be covering finding zeros and exam 2 review. For today, at 1 p.m., we will have Student Success presenting volunteer opportunities and dog fostering with Miss Elizabeth Olivas. So thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for a happy math hour. Have a great weekend, guys.